So thank you for coming to Arduino workshop number 2. We're going to go ahead and get started here. So just an overview of what we're doing today, what we're going to be learning. We're going to be learning about multiple input and output devices. So the input devices are the push button, then the IR sensor and remote. And then output are our LED RGB, our DC motor, and our LCD display. And then at the end, we're going to have some challenges to kind of put all of these together. Overall, this one should be a little bit shorter than last week's. Last week's was a lot more of the basics, so it took, I think, about an hour. So this week, it's going to take about maybe like 30 minutes to get through all the content, and then about another 30 for the challenges. All right, so let's get started. So start with our inputs and outputs. So first thing we're going to be going over is our push button. So our push button, it looks like this, and what it does, it connects two parts of the breadboard together and allows us to have 4 different signals connected to each one of these terminals. And what it basically does is it closes this bridge between the AD nodes to the BC nodes. And what we're going to need for this example is we're going to need a push button, a 500 ohm resistor, a 1 kilo ohm resistor, Arduino, breadboard, and LED. So we're going to go ahead and get started with that. And the first thing that we're going to want to set up is this TinkerCAD circuit. So I'm going to go ahead and walk us through it. First thing we're going to do is power our breadboard and ground it. And then we're going to want to power the push button and attach a 220 ohm resistor to that and ground that as well. So I'm going to go ahead and start that over here. So let's go ahead, look up Arduino. Zoom out a little bit. Breadboard. Again, we're going to work with a smaller breadboard, same one as last week. So let's go ahead and ground this. And same thing as last week, using that format where we have our ground wires as black wires and our powered wires as red. Next thing we're going to do is look for that push button. There you go. Here it is. And then what we want to do is we don't want to connect it here. We want to make sure that it crosses this middle barrier here. Why we're doing this is because we want each of these terminals. You see terminal 1A, terminal 1B, terminal 2B, terminal 2A. So you want each of these terminals to be connected on its own to its own separate node. And so next thing we're going to do here is we're going to be, let's connect a resistor right here. And then we can go ahead and rotate, rotate it. I want to rotate that here. And then we're going to go ahead and ground this. Make that black. And then we're going to go ahead and power this terminal 1A. Okay, now we're going to work on connecting a signal to this terminal here. And how we're going to do that is we're going to connect one of these, our data wires, from terminal 2B to the digital pin 2. Let's get that started. We could bend these around like that. So I'm going to use the same consistency, make it all yellow. And now we're going to set up our LED circuit. So we're going to do this the exact same thing as last week. We have this digital pin 13 connected to a resistor, connected to an LED, and then we're going to ground that LED. All right. So let's go ahead and do that. So this cathode, as we see here, the cathode is always grounded. Cathode black, and then we need a resistor. Let's go ahead and rotate this. connect this to a different terminal, and then we want this. This is going to be our signal end right here. So we're going to be sending a signal into this anode across this resistor. So from this terminal, we want to connect that to pin 13, make that cable yellow. Okay. So now we have that our circuit set up. So now we're going to go ahead and get our code all ready. So the point of this code is to have the LED, the natural state of the LED is going to be off. And then when we press the push button down, that push button is going to hold the LED on. So as long as we're holding that push button down, this LED is going to be on. But once we release that push button, that LED is going to be off. So first we have to, again, we're not going to be using blocks. We're using text, continue, integer. What do we want to call this? Let's call this LED is equal to 13, integer push button is equal to 2. Okay. So then we have pin mode, LED is equal to output. As we see here, pin mode push button is input, but we have to remember to start with this serial begin 9600. Serial.begin 9600, and then pin mode push button input. So that matches up here. And now we'll go to our void loop. So we're going to initialize this button state, and it's going to be the digital read of the push button value. So this digital read is the opposite of the digital write. So it takes the data from this digital pin and basically absorbs the value that is sent through this blue cable. So if it's pushed down, then it's going to send a signal here that is being pushed down. If it's not being pushed down, then it's going to send that corresponding signal saying it's not being pushed down. So integer, let's delete this. Oh. State is equal to digital read, digital read push button. And then we have the serial print button state, and that's basically going to make sure that the data is being absorbed in properly. So this is going to print out zeros if it's not being pushed down, and 1 when it is being pushed down. So serial print dot print ln button state. Next, we're going to write this short if loop. So if button state is equal to 1, so if the button is being pushed down, digital write LED high, we're going to turn that LED on. Inversely, if it is not being pushed down, we're going to turn that LED off. So digital write LED low. And then this delay is just to make sure that our system runs smoothly. So that there's a little bit of a delay before absorbing that data. Digital write LED high. Then we close bracket, else digital write LED low. And then we're going to go ahead and close that. All right, so once you have this all set up, go ahead and test it. And let me know if you have any trouble setting that up or testing it out. All right, do you have it all set up? You could, I think there's a button where you could just press the thumbs up.
It's giving me some errors. I'll check.
Let me see. Okay, yeah, it's giving me this. Let's see. Void setup. Okay. Pin mode, LED output. Pin mode, LED output. Okay, that's weird. Let's try this. I'm gonna try. I see. I have this inversed, so it should be lowercase begin, capital uppercase serial. So that should run it there. So if I think you probably had this as a capital B like me, and then this should be the capital S, and this should be a lowercase s, and that allows you to run it. Oh, code. Let's open up the code, and then we could read this serial monitor. Let's go ahead and clear that. So yeah, data clear. And then you can see as you're holding it down, it gives out 1. And once you release, it gives off 0. So 1, turn on the LED, 0 is turn it off. Is that working for you now?
Can you go back to your code?
Yeah. So let me just drop this down. So the only thing I changed, well, the only thing that needed changing was this right here. So the language is extremely case sensitive, so that was my bad. This should be a capital S on line 6, and then a lowercase b for begin. So capital S serial, lowercase b begin.
Okay, yeah, got it.
Cool. So go ahead, press the push button, look at it start, get it turn off, and that's the general gist of the push button. It won't hold the value, so it's not like a switch. It is just in that instance where you need it to connect the terminal 1A and terminal 2A. These sides are connected, as we see. So terminal 1A, terminal 2A is corresponding. So A is terminal 1A and B is terminal 2A. So these two are not connected on one side. So what this does is it bridges the connection between this side here and this side here, and allows for the signal to run through this power signal. So that's what that's reading. It's reading that there's power going through, and that's where you get the 1. So it's basically reading a high value of power. Okay. So any questions? Oh, sorry, go ahead.
So which ones are connected again? Could you repeat?
So terminal 1A and terminal 1B here are connected.
Okay.
So this is being powered here and grounded here, but this is not, it's not connected from 1A to 2A. So the terminals 1A and terminal 1B are connected. And by pressing down the button, it allows power to go through. And that is what this data cable is receiving. It's receiving that there is power going through. So that's why the only values that we're reading were zeros and ones. So 0 was no power going through and 1 was power going through.
Okay, thank you.
Okay. So I'm gonna go ahead and move on to the our next input output, and that is going to be the DC motor. So the way that a DC motor works, it's a pretty basic concept, but it can get more advanced if you want to take classes in that. So basically what it does is the positive terminal gets powered. It runs current through this through these cables here, and it creates a magnetic field that causes the metallic pieces around it that are not connected to these electric cables to move. So that's basically what it does. It applies an electric current that creates a magnetic field, and that gets the metallic pieces around it to move. But right now we're just going to mostly be working with the basic circuits of it. So what we're going to need is a DC motor, a 1 kilo ohm resistor, a push button, Arduino, and a breadboard. And we're going to go ahead and set up this circuit just like this. So we're going to, let's go back to TinkerCAD, just start one from scratch. So first thing I'm going to do is set up the DC motor. So there's going to be one connected to the digital pin 3, connected to the black side or the negative side, and we're going to power the DC motor, connecting it here to the power terminal of the breadboard. Okay. Let's go ahead and look for Arduino. Okay, so let's go ahead and first we're going to go ahead and ground this black, and then power this red, and then DC motor. Okay. Let's look at that, and all right, there it is. We'll go ahead and rotate this. So terminal, we're going to power terminal 2 and here, as you can see there, and then connect the data cable to terminal 1. And we're going to connect that to digital pin 3, yellow right there. And then what we're going to do is we're going to set up our push pin again. So let's go ahead and set that up. Push button. So we're going to power one side of the, we're going to go ahead and power this side here, and then connect a resistor here. I'll go ahead and rotate that. Then ground this end of the resistor, and then connect the signal cable from the same node connected to the ground. We're going to connect that to digital pin 8. So here, digital pin 8 right there. And that's our circuit. So what we want to do is we want to control this DC motor the same way we controlled the LED in the previous exercise. So whenever we push this down, the DC motor is going to run. And whenever we release the push button, it is going to stop running. Okay, so now let's get that code started. So let's shift this over a little bit, code, maybe a little bit more. Text, okay. Okay. So let's initialize integer button is equal to 8. and then integer motor is equal to 3. Then pin mode 8 is input, and pin mode 3 is output. And what we're going to need in that setup is just that. Actually, let's go ahead and replace these with button and motor. All right, so that's our setup and initialization right there. Next, we're going to work on this loop. So it's integer state button is equal to digital read button. Let's delete this. Okay, there we go. And what we're going to do is if button is equal, oh, nope, not like that. So it's if state button is equal to 1. If state button is equal to 1, digital write motor is equal to low. Then else digital write motor is high. So this is actually going to do the opposite of what I said. I mixed them up. So it's going to take in the value of the push button. So if it's pushed down, which is going to read a 1, then the motor is going to turn off. And when we release that state button, it's going to be 0, and that DC motor is going to turn off. So let me know when you have that code set up, and you can go ahead and press start simulation to check if there's any errors.
Why did we switch it this time?
Sorry, switch what specifically?
Like how when the button is on, the motor is, oh, it's on.
So here it's actually reading low. Let me see what's. So when I press it,
we connected to the positive terminal.
I believe so. Let me try switching some things up. So this is the power. So if digital pin 1 is equal to, let me see. I'm gonna try and I'm gonna go ahead and print this. So print what values we're getting, just so we can verify that we're doing this right. So serial begin 9600. Okay. Let's see. Let's go ahead and stop this. I'm gonna put a delay so that we can see the values better. I'm putting a delay of 500 milliseconds, which is half a second. Let's see. Oh, I forgot I closed that. Okay, so let's see, when we push that down, we get 1. I press that down, that's 0. So when 0, it's off, and 1, the DC motor is on. Does everything make sense so far? Are you having any issues?
I get it, but it's like, is it good practice to connect the motor to the negative terminal to ground or to 5 volts?
So this is powering. So this, yeah, it's kind of a weird practice. So we can go ahead and try what you're saying, which I think will work the same. So I'm gonna go ahead, I'm gonna stop the simulation really quick. And give me 1 second, I'm gonna mute my mic as well while I run through this. So let's go ahead and do what you're saying, which I think it makes sense. You're right. So now we can go ahead and run this. See, yeah, you're right. So what it was doing before was, since it was connected to the ground terminal, what it was doing was it was blocking the power from going through. But when you press 1, it was allowing the power to go through. So it's kind of doing the opposite of what makes sense. So now we could see that when we press this button, the DC motor is going to stop. And there you go. Once we release it, it's going to continue running. So yeah. All right, that makes sense. That was a good catch. Do you have any issues running it?
No, it's all good.
Awesome. All right. And do you have any questions about the DC motor?
Is there like the third output that outputs like position or something like a servo, or is that different?
Yeah, there's a servo. They do have a servo. Here, let me close it. So they have a couple micro servos here, and that's actually I have the lecture slides or the Arduino for next week is gonna cover servos. They're a little bit more they're a little bit more complicated. So the concepts that we go over in that Arduino are prepared for that, and we're just gonna be a whole challenge with it.
Okay.
All right. Well, that was the second output, or that was the second thing that we're gonna go over. The third thing is we're gonna go over RGB LEDs, and I'm just gonna go over here really quick to kind of show what that is. So an LED RGB looks like this, kind of looks like a squid. And the way that it works is that it takes signal values for the 3 main colors. I believe they're called primary colors, but I'm not sure. It's been a while since I've learned something like that. So it has R, which is red, G, which is green, and B, which is blue. And then it has, of course, our cathode, which is our ground. So we're gonna go over how it makes those colors real quick here, just by clicking this. So what white is, in the sense of RGB LEDs, is the signal 255 flooded into all 3 nodes, which are going to be R, G, and B. And you kind of see how we can get different colors by either increasing the magnitude of red, decreasing the magnitude of green and blue, and so on. So if you remember from last week, the reason that this number is 255 is because Arduino works in terms of 8 bits. 2 and 2 to the 8th power is 256, but we start with the number 0. So it goes from 0 to 255. So that's also how binary works, but that we're not going to get into that today. So you can pick a color that you would want your LED to be using these sliders. And then by using any of these combinations of signals, that allows us to create a multitude of colors. And the amount of colors that you could create using the RGB LED here is 255 to the 3rd power. So that's a lot of different colors. So our next example is just it's a little basic, but it's just gonna show all the different colors that can be generated by an RGB LED. So we're gonna go ahead I'm gonna create a new circuit really quick. And what we're gonna be needing is the 3 220 ohm resistors, an Arduino breadboard, and a single RGB LED. Right here. We'll be connecting these side by side, as a matter of fact. And then let's connect this here. Okay, and green goes to 13, ground goes to ground, of course. Green goes to 13, blue goes to 12, and red goes to 11. So let's do green goes to 13. And by the way, you could create these bends by just clicking along these axes. So you click it once to hold it there, click another time, and it'll hold there, and then click it lastly down here. So that one's blue. Let's connect this one to ground. That's black, and then we have red. Oh, let's do this again. We have red here. Connect it to 11, and let's make that red. So just using these 4 pins, we could send a signal that we're going to be creating randomly generated colors using this RGB LED. And we're going to be using slightly different syntax for initializing our pins. So initializing our pins as we've done it before, so integer button, integer motor, that works as well, but just so that you have a different, you have different methods of initializing your pins, we're going to teach you the define code. So we define, that's got to be all capital. Oh, nope, actually got to be all lowercase, my bad. Define LEDR, and there's no equal sign. You just list the number that it's registered to. So go ahead, # define LED blue. So we're going to do B 12, and # define LED G 13. There we go. So we're going to have LED R output. I'm going to go ahead and copy this because we're just going to paste it 3 times and make a minor adjustment. So this is B and this is G, just as we have it here. Now what we're going to be, the program we're going to be implementing is going to generate random numbers between 0 and 255. And we're going to be sending that signal into the LED. So let's go ahead and do that. So we're gonna set integer r is equal to 0, integer b is equal to 0, and integer g is equal to 0. Okay. So now we're going to use the random function. And we actually want this outside of both the loop and the setup. And so r is equal to random between 0 and 255. We're going to close that. B is equal to random 0, 255, and G is equal to random 0, 255. And just for the sake of learning and us being able to see the values, I'm gonna make sure I'm gonna include serial print. So I'm gonna do serial begin 9600, close that, and then serial print. We're gonna do serial, let me see, serial print, serial dot print R. Let's go. I'm just gonna copy paste this 2 times, and this last one is gonna be a new line. So, and then I'm gonna include space between each of these. So B plus space RB and G. And then this is going to create a new line. So what this does is this prints our numerical value of R, prints a space, prints the numerical value of B, prints a space, and prints the numerical value of G, and then completely indents it. And now we're going to digital write to our LED, or analog write to our LEDs. So analog writing is the same thing as digital writing, but analog writing allows us to send values between 0 to 255, while digital writing only allows us to send the value of lows or highs, zeros and ones, ons or off. Let's go LED R, LED B, analog write LED G. All right. So are there any questions so far with the code, with the schematic, anything that we've done so far?
No.
Cool. So I'm gonna go ahead and run this. Oh, I forgot to include a delay. That's why it looks like that. All right, so what we're gonna do is we're gonna include delay, and just so that we could see it, I'm gonna include delay 5000, which is the 5-second delay. Now we're gonna go ahead and start that again. Let me see. Okay. I believe we forgot. Yes, that makes sense. So, teachable moment, I guess. So the LED broke because we did not include resistors, or I guess I did not include resistors. That was my fault. So when diodes receive an excess of current, they're prone to blow. So that's what the resistors do. They diminish the current by increasing the resistance of the circuit. So if you want an extremely low current, you include an extremely high resistance. So that's what we're missing here. So I'm gonna go ahead, move this node over here, this node as well. There you go. Whoop. And now we just need some resistors. There. And we could leave them as 1 kilo ohm resistors. So the way resistors work, the higher the resistance, the lower the current, but also the lesser brightness that you will have coming out of this diode. So what you want is you want to pick, if you're doing circuit design, you want to pick a resistance that's low enough to get the maximum brightness out of this diode, but high enough that you're not going to burn out your LED. So we're going to go ahead and try that again and try not to burn out this LED. You can see that the LED is changing colors every 5 seconds, depending on what numerical values we're feeding into the LED. Any questions so far?
Serial monitor.
Oh, I see. Okay. So the serial monitor is not printing properly, or at least not the way I'd want to. So what I would want is this number. I prefer to have a space. So I'm not too sure how to do that, but I'm gonna go ahead and Google it for us. So all right. So it appears that instead of this, let's go ahead and delete this. Oh, gotta stop our simulation first. We're gonna have a tab. And I'm gonna go ahead and try that. All right, let's try this again. Okay, let's look more into it. I see. Okay, so this needs to be in quotations. All right, let's try this again. Expected. Let me see. Expected string constant before 2118. Do you see an error with the code? I'm not too sure if I see one.
I think you just can't do it like that.
Okay.
I just had separate lines for
Oh, I see.
space and comma.
Oh, I see.
I don't know if there's like a better way to do it.
So you had it more like that?
Yeah.
Okay. There you go. So these are signals that are getting fed into every respective node here. So red, blue, and green. Okay. So what I'm gonna try and do here is I'm gonna try and reduce these and see if it actually changes the brightness of them. All right, so let's try and run that. Actually, I don't think it makes much of a difference because it's on a monitor, but for me, it looks a little brighter. I don't know if that looks the same way on yours, but decreasing in, if you were to design this circuit in real life, if you were to swap out a 1 kilo ohm resistor for two 20 ohm resistors, it would look, this should look a lot brighter. All right. Do you have any questions for this example?
No, you can move on.
Cool. So the next we're gonna be doing is something a little more fun. We're using the IR sensor and the remote. So we're gonna be, it's gonna be a very basic exercise. It's implementing an IR sensor, remote, and LED. So we're gonna be turning that on and off in this exercise. So IR sensors are found basically everywhere, and we don't even really are aware that we're using it. So if it's IR stands for infrared. Infrared remotes are used for television and sometimes gaming controls. They're used in a lot of our everyday life. And basically what it does is it sends a signal of ones and zeros from the remote, and the TV will have a sensor. And that is really basic, but it's super cool and it's still used today. But first we're gonna learn about a little bit of the switch case loops. So the way that a switch case loop works is we're gonna have a case up here, a single expression at the very top. And that single expression could be the, let's just say we're looking for something in a grocery store. Let's say we're looking for apples. So this expression will be apples. And let's say this expression here is bananas. Then we are not going to go to the code block. And then let's say this is watermelon. We're still not going to go to the code block too. And let's say that finally down here, we have apples. Then we're going to run a code block that says pick apples, like pick a dozen apples or whatever you'd want that code block to say. Lastly, we have to remember a default code that will run if the switch case can't find any values that exactly represent this. You could put it as go back and look again, or say, okay, just go home without apples. And that's basically how switch case loops work. And we're gonna get a little bit of practice at that right now using our infrared sensors. So first we're gonna go ahead and set up our circuit. What we're gonna wanna do is connect we're gonna first wanna ground and power our breadboard from our Arduino. Then we're gonna set up our LED by connecting the anode end to our signal, our digital pin 13. So let's go ahead and do that first. Stop simulation here, and I'm gonna go ahead and run another one. All right, let's Arduino here, breadboard, small. So let's go ahead, we're gonna power this. Make that red, we're gonna ground it as well. Make that black. Then we need our LED. We're gonna connect that here. Then we're gonna ground this terminal. Then we need to include our resistor so that we don't burn out our LED like we did last time. And let's go ahead and connect this terminal to terminal pin 13 here. All right, now we're going to work on connecting our infrared sensor. So our infrared sensor doesn't need anything besides our cables and the remote. So let's go ahead. Infrared sensor here. So connect that here. And remember, it does show you where the pins need to be connected to. So ground, we're going to obviously ground that. Power, we're going to power that through here. Let me see, I want to do it all the way through. There you go. And lastly, we're going to connect this pin. Let me see. I want to connect this to, we're going to connect this to pin 2. Make this yellow as well. All right, so this is our circuit, and we want to make sure to include our IR remote here. So we're going to go ahead and move this over just because the IR remote takes up a lot of space. Text, yep. And now we're going to set up our code. So today we're also going to be going over a new concept. And in Arduino, that concept is called libraries. So as you see right here in the first line of the code, it says include IR remote.h, and that basically includes the IR remote library. And in that library, there's specific, what's the word I'm looking for? There's specific dictation, such as this IR receive word here, and this decode results here. So if you try to run this program that we have between the lines 2 and 27 without this library, it would not work, because without the library, you would not know what the Arduino would not know what these words meant. That's why they're called libraries. So the library introduces new words to the Arduino program that it will not know otherwise. So we're going to go ahead and get this set up here. So first, include IR remote.h. I'm gonna go ahead and split screen this just for the sake of making this copying down a little faster. Oh. Integer receive pin is equal to 2. IR receive let's see. And then decode underscore results. We have the void. Serial begin. And then IR receive dot enable IR in. And then we'll have this void loop. Inside the loop, we're going to want to have that if IR receive dot decode and results. and results, open brace. I have open brace, 0.print natural log of results dot value, comma, hex. And hex is just hexadecimal. And then we're gonna have this switch case that we were talking about earlier. So switch results dot value. So case 0x fd 08 f7. And then we're going to use colon, not semicolon for that one. And then we have digital write 13 high. And if this runs, we want it to break. And I'll go over a little bit more of what that means later. 0x fd8877, again, colons, and then digital write 13 low. And then again, another break. And then at the very end, we end it with a semicolon, and then we have IR receive dot resume. Close that, close our if loop, delay it by, we're only gonna delay it by 100 milliseconds. And then we're gonna close this up. All right, so there's a lot of code. I know it's a lot more complex than what we've gone over before, but I'm gonna just go ahead and walk through it really quick. So all of this language, this initializes our setup. So this allows us to receive IR signals. This is going to print our IR values in hex, which is hexadecimal. It's just another way of reading numbers. We have binary, decimal, which is what we're all used to, the decimal system, and the hexadecimal system. Switch, so this results dot value. So that is going to be what's returned from here, and what's also going to be printed here. So we're going to be looking out for a signal, and dependent on what that signal is, it's either going to match our first case here or our second case here. And if it doesn't match either of them, since there's no default, it's just not going to run. So let's go ahead and start this up. Do you have any questions before I show you what it does?
I'm still writing the code.
For sure. I'm gonna give you a little bit more time. Just let me know when you're ready to move on.
Okay. I'm getting errors. Yeah. Okay, there are no errors. I just missed a few semicolons. Yeah. Not for now. You can move on. It's taking a while to set. Do each of them have like some meaning to them?